Okay. Inheritance. How much money Grandad's got? I've no idea. We're looking at the business of effectively. Here's the thing. Question for the audience. This is going to go well, Rob. Why is inheritance a good thing to do? Why do we use inheritance? What is it that makes it fun, interesting and vibrant? Bloke at the front gets the answer right first time. I hate it when that happens. Can we have a few wrong ones from the back next time as well? Because you only want to ever do anything in your life once. One of the reasons why I mentioned why I hate gardening before. I don't like gardening because gardening, you mow the lawn, cut the hedge, trim the trees, do the stuff, and in 3 months' time you have to do it all over again. A gardener does not stay gardening. You have to keep doing it. I don't like gardening. I'm a programmer. Programmers do things once and precisely once. To that end, they're what you might call creatively lazy. They think of ways of avoiding work which are harder work than doing the work itself, which is going it a bit, but that happens too. Programmers are very keen on laziness. There are good reasons why I'd only ever want to write it once, apart from the obvious, I only have to write it once. What's the main reason why I like the only write it once approach along with laziness? Easier to maintain. What it means is if I find a fault in this code I wrote once and once only, I fix it once and once only, it's mended forever. If I had my way, if I had that power, I'd make sure that in the programming lab in Fenner, Control-C and Control-V didn't work. Block copy was impossible in the lab because block copy is evil, it is never your friend. If you find yourself block copying lumps of code around, then you're kind of repeating the same action in several different places, and that's kind of like a bad thing to do. So yeah, for me, you wouldn't get block copy till the 3rd year, and even then, not always. It's a bit too dangerous. So, write things once, have every behavior in one place only in your design, and then you can fix it. The flip of that, of course, is that also means you can test it. So if I've only written it in one place, I can make sure that one instance of my behavior is a very solid component, and at that point I can have a lot more faith in my code. So, to that end, we looked at bank accounts and we came to the conclusion that, yep, okay, we have an account behavior which will be, I don't know, 10, 20, 30, 40, 90% of what a bank needs to do we can put in the bank object, that's fine. But we sometimes need to customize the behavior of the bank to make different kinds of bank, and I sort of came up with this idea of the baby account in my bank, which is based on the account class, but it replaces the withdraw funds behavior. Now, we're not unused to making accounts, we're not unfamiliar with the withdraw funds method, and the line we heard from the bank manager was that a baby account is like an ordinary account, except it can't draw out more than a £5. And so we build that business rule in, but we do it by overriding the behavior in the parent class. So the account class, if I wobble up here, has a withdraw funds method, and the baby account class, which is based on this, also has withdraw funds. Now, thing to bear in mind, this is the parent. The parent has marked the method virtual, which means anyone that fancies overriding this behavior can do so, and the child class has marked it override to say, yes please, I want to do this. So if they're asking for more than a £5, we give up straight away because they're not allowed to have more than £5 in any given withdrawal because they're babies. Otherwise, and this is the clever bit, I call the withdraw funds in my parent because that can then sort out taking the money out of the account. I know it's okay to do it, so I call the method that does it. If I run through the example code here using breakpoints and single stepping, then that'll hopefully make it clear as well. So we run the program up, we hit that break point, we step in to the withdraw funds method inside the baby account class. Is it more than 5? No, it isn't. So we drop through and keep going. We call the withdraw funds in the account class. We go up here, we do the work, return true, and all's good. So, is everybody okay with that? The fundamental starting point is, I want to write my code in one place, and I want to reuse the absolute maximum code that I can, and I want to provide the tiniest possible amount of delta, the amount of change, when I make myself a child class. Let's just try something not on the script. What happens to my program if I do that? What have I done? Storm of apathy. No one cares. What is A? A is a reference that can point to accounts, and I've made it refer to a baby account. Ooh. Can you see any wavy red lines? Nope. Do you think it'll work? How many think this will run and compile and run okay? Okay, how many think it won't? Okay, there's a fair few people who aren't thinking at all. Fair enough. That's okay, I get paid either way. So, turns out it'll work fine. Run the program, hit the breakpoint. It does exactly what we would expect. It calls, which withdraw funds is going to get called? Because A is a reference to a baby account, it'll call the withdraw funds for the baby account. In it goes. Stop that. Make another tiny change. Take the word baby out there. Will it compile now? Absolutely. Run the program. Which version of withdraw funds gets called now? The account version. I mean, I'm probably labouring a point here. There it goes, into the account version. But there's two things I want you to understand which are really, really important. First thing, a reference to the parent type can be made to refer to any of the children, because all the children can do what the parent can do. So a reference to account can refer to baby account or current account or checking account or credit account or any of the account children. Okay? So that's fine. In fact, what I would do in my real bank is I'd have a list, so we say, of account references, and I'd econ and I'd call it bank, and I'd equals new list of account references, and now I could add my accounts to the bank and all that kind of good stuff. And the really sweet thing about this design is that that means I can put baby accounts, current accounts, credit accounts, any kind of account I like in there, including new ones we haven't invented yet. So I've got a way of future-proofing my bank now, because if any new accounts come down the track that I haven't heard of, fine. Pick the one they're nearest to, extend it, add the overridden behaviours that we need to get it to behave in the way that we want, and then we can create instances of those guys and slap them in the same list. Is everyone okay with that? Does that make sense? The fundamental principle of hierarchies is that reference to the parent at the top can refer to any of the children. However, get rid of that. Just, can I do something like this? Baby account A equals new account. Ooh. Wavy red lines appear. That's probably going to indicate trouble brewing. Why is that not going to work? Who can do most, parent or child? Child. So the baby account could have a method called googoo. Say, what would there be in a baby account? Okay, right, okay. Baby account has a method called googoo. Right, fine. So I can go x.googoo, where x is a reference to a baby account. Does the account class have a googoo method? No, it doesn't. So in this situation here, I couldn't go a.googoo because the account doesn't have one of those. Because the account is the dumbest one, we can't have references from the clever children referring back up to the dumb one at the top. So we can be absolutely sure that all the children of account can do what account does. We can't be sure that account can do what the children do. So you can refer down, but you can't refer back up again. So keep that in mind, and I'll go back to the plot now, which is here. So we have this thing about virtual. We make methods virtual when we want to override them. As it says in the slide, some methods we probably don't want to override. We leave those as just as they are. Other methods, like say withdraw funds, we might make that virtual. We can then override it in the child classes. Now, this is something which we now need to build on. Well, it's not interesting, it's kind of boring. If you look here, there's nothing there's no constructors inside my account class or my baby account class. Anyone can tell me what the constructor does? When do we use constructors? Yeah? No? Whatever? When we make a new one, we use the word new and we call the constructor for the object. So that means that I could, for example, if I thought it was a good idea, and it might be, and it's in the notes, so we should do it, public account, no, that's later, account, and we'll give it a balance value eventually, and then we'll say something like balance equals in balance. So when we create the account, we can now set up a balance. So down here I could go account equals new account £200. So this guy gets 200 quid. Does that kind of make sense? All right with that? Okay. But we now have a problem, because the system is saying don't like baby account anymore. I'm getting an error there. If I go on there, it says there is no argument given that corresponds to the required formal parameter. What the compiler does is it figures out the most confusing way to explain what's going on and tells you that way. What it's trying to tell you is that, hey, baby account is based on account. So to make a baby account, I have to have the parent object. Snag is that at the moment, to make an account, I need a balance value from somewhere, and you haven't given me one. So what it's telling me is that if I want to make a baby account, I have to create the parent object, and to do that, I have to have a balance, and at the moment, I haven't got one. Back to the slides for a second or two. Where are we? Yeah. If you want to have a baby account, you have to have the parent object. And so if we do this, which I've just done, then I'm now going to get an error when I try and make myself a baby account. And what you have to do is this. You have to add a constructor to the baby that says, okay, I'll do whatever we need to make a baby account, but before I do that, I'll call base, which is the thing in yellow, which is the constructor in my parent. So watch this and we'll go through the code and get out the other end. So if I go public, okay, that's good, public baby account, this is my constructor, and I'll give it decimal in There's my balance going in. Now, I have to put a colon here, because this is how the syntax works. Base. Give him the imbalance, because he's the one that really wants it, and then my constructor does nothing. Now, just think about the philosophical ramifications of this, if you like. To make the child, I have to make the parent. To make the parent, I need a balance value to feed into that parent creation process. That's what this statement here does. I can show you it in action by just going and changing you to a baby account, and then you to a baby account, eventually, and then run the program, and we'll watch the construction process go through. So I'm making a baby account called A. Here we go. Step in. It goes into the constructor for the baby account, calls through for the one for the parent, does the parent stuff, drops through that, and then does my stuff. So this statement here enforces the creation of the parent object before we set the child up. That's absolutely crucial. In fact, someone came and asked me a question right in the lecture yesterday, which was on the lines of how does construction work in hierarchies? The answer is like this. We need to have a balance value to feed into the constructor for the parent class. We get it from the user. I could be stupid and do that. That's perfectly okay. That means that every account that gets made has got £0 in it. That'd be kind of stupid. So what I will do is I'll feed in the value that was fed into my call. If we could have a baby account that contains the name and address of the parent or guardian, the baby. We could feed that information in here. So what I would do is I'd have in my baby account, I'd have string parent name, say, and then in here I get feed the name into the constructor for the baby, and then parent name equals in parent name. So that means that I've now got like 2 levels of setup, and then in here I now have to scroll down to the bottom here and make an account with balance of 200 quid and a parent name of Fred, say. So now run the program again, and what we find now is it hits the construction breakpoint, step in there, we set up the account instance, there it goes, with the balance. Now we drop through and set the baby up with the parent name of, when it goes over, Fred. So, does that make sense? You get this problem every time in any language where you use class hierarchies. Java does something very similar when it does it. Python does something similar-esque when it does it. It has this constructed sort of mechanism for doing this. So you do have to address this problem every time you use inheritance. But that's fine. It's just a thing that you do, and you can see why. Any questions on that? Oh, that was easy. That's good. I'm happy with that. That's good. So yeah, when you build your class hierarchy, you figure out how much information each class needs to set itself up, and then when you add them in, you figure out how the constructors link together and how you chain through. So it's a very important aspect of class design, because if you get it wrong, then your classes will, well, you get compilation errors and things like that. So don't get it wrong, basically, is the answer there. So now we're going to explore the bit that I've already alluded to, which is references. Now, everything in a class hierarchy is managed by references. One of the golden rules in C#, you cannot build a class hierarchy that contains value types. You can't put structures in a hierarchy. A structure is basically a lump of data. If you think about how classes work, a class in a class hierarchy isn't necessarily a lump of data. It might be a lump of data that holds the account, followed by a separate lump somewhere else that holds the baby account bits. So when I make a baby account, there are effectively 2 lumps of memory used, one for the account bit, one for baby. We don't know how that works. We don't care because C# hides it from us. But we don't have to think of our objects as being anywhere in memory we can make use of. But structures aren't like that. A structure is basically a fixed size and cannot change. So structures can't be used as the basis of class hierarchies. They're strictly lumps of data. But in C#, yep, everything in the object world, we can make class hierarchies from those, and we can manage them by reference. So this is basically me going through chapter and verse about what I've just showed you, and the bottom, the bullet point, the child can always do more than the parent, is the thing to bear in mind here. Every time you add a layer, you pick up behaviors from the layer above, and in terms of references, that means that, as I was just telling you, if I've got a reference called baby ref, I can withdraw funds from that. If I have an account called account ref, the key line on this one, I'll do it with the arrow so you can see. This line here is the kicker. That's the most important one. A reference to account can refer to a reference to a baby. When I call this method here, we're going to use the baby account withdraw funds because at the moment that's the type of object which account ref refers to. The good news here is it tends to just do what you want it to, which means that what it'll do is it'll basically call the method that has been overridden and is the appropriate one to use. So irrespective of the type of this reference, as long as it's legit, we'll call withdraw funds on the baby because that's the kind of thing it's referring to now. Does that make sense? It'd be crackers to make it work any other way, which makes me wonder why Python doesn't do it. Okay, moving on. Fair enough. Tough audience, I can live with that. The parent's the dumb one. The parent is the one that can't do as much. So references to children can't refer to parents because the parent might not have that behavior, and the compiler says you're not allowed to refer back up the tree. And so, yeah, here's Robert's fully worked example. And look at that, we're talking about parent names. Who'd have thought? Almost like I've done this before. So, we put a parent name inside the baby account. We have a method called getParent, which actually gets us the name of the parent. And we set this up in the constructor as you have seen. That's all fine and dandy. That's how you want it to work. But I can't make my account ref equal to a baby ref because I can't call getParent on this guy. It doesn't exist. There is no getParent method in the account class. That lives in the baby account. So we can't ever make a reference refer to the wrong, basically a child reference can't refer to a thicker parent. We can't refer back up the hierarchy. Does that make sense? I mean, the good news is that generally speaking, because you work on the basis that your collection of accounts will be the topmost type, then you'll be absolutely fine with this. You won't see this error because you just won't do it this way. Everything, all your containers can. You'd never make a container of babies because you'd make a list of accounts instead. Much more sensible, much more future-proof. The compiler checks through all this, and so it gives you the errors if you do something which it doesn't like. And like it says, the real power of references and hierarchies is that we get whatever behavior is appropriate when we try and use it. Second bullet point's really important as well. One of the problems with class hierarchies is how annoying they are to save and load, because when you save the baby account, you have to save its parent, its name of its actual, the baby's parent. Then you have to save all the parent data from the parent object. So it's a very confusing way to use the word parent, Rob. Good plan with that. But we can override the load and save methods to make them work sensibly. So let's have some fun with this. I always like this one. This is the kind of thing you do if you get a job at Argos to write their stock control system. At the top we have stock item, which I quite like. Underneath that, I don't know if Argos sell clothing, they might do. They have a total class hierarchy dropping down there, clothing, dress, trousers. Down on the electrical side we have TV, dishwasher and other bits and pieces that they might actually sell. So the thing about this is that everything is an item of stock. So what are the kind of things we'd put in the stock item class? Say again?
Stock count.
Stock count, so how many of these things we've got, that makes sense. Anything else? Price, yeah. Anything else?
Where it is.
Physical location. Oh, I'm getting a thing that's buzzing. Go away. Oh no, wrong one. Go away, go away, go away, go away, go away. Go away, go away, go away, go away. Thank you. So all the stuff to do with being an item of stock goes in there. What about voltage? Input voltage range. Where does that go? Clothing? That will go in electrical. What about number of serving capacity? Number of place settings. How many cups and dishes can we put in this thing? That's going to go in there, isn't it? So the nice thing about this design is that we're actually able to add new types. If I'm going to start selling jewellery, then we can put that at some point in the class hierarchy and have those things behave in a manner appropriate and in data appropriate to items of jewellery. So it's actually very useful to be able to do this. This is, I put the slide up because if you go for a job with Google or Apple or Microsoft and they give you a telephone interview, which they probably will do first to decide if you're worth hiring or not, they'll ask you questions about class hierarchies because it's a good thing to talk about over the phone. And so they'll try to find out whether you're clever or stupid. This is a clever piece of class hierarchy because everything at the top is kind of based on the same thing. These guys are all items of stock. This thing here is basically open season stupidity. Why is this open season on stupidity? I mean, the structure's the same, just the words are different. Pick out some bits of crackersness in there. Someone at the front has said payment has nothing to do with stock item. Now, the answer is you're completely correct. But a designer might go, we have to pay for our stock. Whenever you sell a piece of stock, we have to have a payment for it. So it seems to me that we should have something that extends the stock item to handle the fact that it's payment. That's a really stupid thing to do. Because two things. One is we can't pay for anything electrical, looks like. And the second thing is payment is not part of the stock item hierarchy at all. It's completely and utterly separate. You may have a thing called transaction. You may have a thing which inside transaction refers to the particular stock item that was sold and a particular payment that was made for that item, but you will not put the payment information in the class hierarchy like that. And things like mains supply, I have no idea what that is. And when they think, oh, we need an address on the payment, so we'll put one in here and a receipt for the payment, we'll put it in. This is just a mess. Now, if everybody in the room is going, but that's crackers, then I'm actually really rather pleased. That means you'll get the jobs when you ring up Google, which is grand. The whole basis of the inheritance mechanism is you preserve, if you like, sort of like the sense of the thing at the top. So anything to do with an item in stock should go in here, but stuff like payments, customer records, that kind of stuff, that has to live somewhere else. And so you have to work on that basis. So if someone comes along and says, we're thinking of moving into garden furniture, right, fine. Garden furniture, that goes down here. It's maybe not clothing, maybe we have a furniture thing here, and then we have stock item, and down we go. If they say we have to give everything a barcode, so we're going to put a barcode class that extends, I don't know, something of these guys, oh, that's stupid, isn't it? What about if they put, you get tags on clothing to keep track of clothing in stores, these things that they stick on them. Where should that go? Do we have a class for that? How does that work? In that situation, you don't really need to have another class. You bang it in the clothing type. So does it have a tag? What's the tag called? All that stuff. But you preserve the sort of single-mindedness of your family tree. You don't actually start adding things that are nothing to do with that particular type. So I'm hoping that everyone looks at that and goes, oh my goodness, that's stupid. There's no way that you would have payment as a child of stock item, because payment's something totally separate, nothing the same. If you look at WPF, we've been using that in the labs for a while to build UIs. You find that there's a parent class called UI element, which is effectively the parent of everything on the screen, and that has position and size and a few other bits and pieces, and then below that you have button, text field, text boxes, and text block, text box, and then you have other things going down below there as well. Now, one of the things I haven't mentioned, but you can do this if you want to, it's kind of funky. You can make your own components by extending the existing ones. In the previous version of Windows, Windows Forms, there was no way of making a button with a picture on. But this didn't matter. It just meant you had to make your own button extension that actually put a texture on there rather than a piece of text. And that was all fine and dandy. If you're looking at inheritance from the point of view of good ground rules, these are the rules that Robert has. All the classes in the tree should be related. Everything in the hierarchy should be a version of the item at the top. I'm tempted to go down the animal kind of thing here and that stuff, but that can get a bit confusing. The bottom second bullet point's worth mentioning though as well. Don't make your hierarchy too deep. There's a really good book called Code Complete, which I recommend everybody should read. And there's another book written by somebody not quite as good called Games Programming, Code Complete or something. And it's worth reading for some of the stories, but this guy was involved in a team making an RPG, one of these role-playing type things, and one of the things about RPGs is they have these big inventories where you have all this stuff, correct? And so they were just discovering C++ at the time they wrote this game, and they discovered class hierarchies, which C++ also provides, and they went nuts. They would have sword, golden sword, sword, metal sword, golden sword with jewel, golden sword with, and they built this freaking great big class hierarchy where every single different kind of RPG item in the inventory was a different class, thinking they were being clever. This turns out to be a bad plan. Any idea why? Well, what they found when they built it was that the performance of this thing sucked. It was awfully, awfully slow, because every time they use a method in their object down here somewhere, it has to buzz up and down the tree to find the one that's overridden and use that one. So if you have a 10 or 15 layer class hierarchy, your performance will be fairly poor because of the fact it does this. And also, it's really hard to get your head round. We used to do this thing. Yeah, let's do this, go on. There's my nice hierarchy of electrical, and we go underneath there and we put a fridge down here and a freezer down here, and then someone comes along with fridge freezer and our brain explodes. Is a fridge freezer a child of fridge, or is it a child of freezer? So we've got electrical appliance, we've got fridge, we've got freezer, we've got washing machine, we've got deep fat fryer, we've got Kenwood chef, we've got whatever. Okay, we've got this massive range of objects and a big problem. Same thing with cars, okay? You go sports car, you go people carrier, you go SUV. sport utility vehicle, where does that go? I have no idea. If you find yourself doing that, then you're kind of doing it wrong. In the case of the dishwasher, the fridge freezer thing, you just have a property that says what kind of device it is and a string that describes what it's got, and then you stop. Because I'm pretty sure that you're not really going to have to add massively different behaviors for your fridge to your fridge freezer. You may have to tag things and organize the description of the object in an interesting way, but you shouldn't be adding lots of classes to solve that problem. But once you've got to the point where you have, I don't know, kitchen appliance, and you differentiate that from, I don't know, audio appliance perhaps, because those two things are different, at that point you stop. So don't make your class hierarchy too deep, and don't have tons of classes just because you can. Baby account's fine because it has to behave differently from a normal account. Maybe gold and silver accounts that have different overdraft values. We don't have classes for those. We have a property, are you a gold class, are you a silver class? Can you see where I'm going with this? The bottom bullet points, the real killer though, because I've seen people fall over this one as well. If you get hired by someone to do a clothes shop, you might think that the item at the top should be clothing. So clothing at the top, and then trousers down here, and skirts down here, and dresses down here, and jackets down there. That's fantastic. You build the entire class hierarchy, you go and show the guy in the shop, and he says, oh yeah, we sell handbags as well. Oh bugger. Handbags aren't clothing. Everything falls apart. So that's why Robert always starts at things like stock item, because stock item is properly abstract. So I have a policy now of taking a look at my top class that I've identified and saying, okay, is that abstract enough? Am I standing far enough back? And what is this thing really? And it isn't a piece of clothing, it's a piece of stock. And once you get your head around that, then you can expand stock into jewellery, handbags, belts, and all kinds of other accessories. So the takeaways are, don't go nuts with this. Don't add lots of classes just because you can. Don't make your hierarchy too deep. Modern wisdom is a depth of about 4 or 5 or 6 is probably optimal. If you look at the Windows presentation foundation stuff, it goes down about that deep and not much further. And make sure that you've got appropriate levels of abstraction at the very, very, very top. And that will help. Any questions or observations on this aspect of inheritance, construction, all that kind of good stuff? Anything? Okay, in that case then we'll go on. So, I like this stuff, abstract classes, yay! Oh no, wrong button, hate when I do that. Don't forget, in case you've forgotten, Friday morning, 9:15, special extra lecture for this course, all about the coursework. Come along, bring a friend if you have one. Mind you, yeah, you're a computer scientist, odds are not great. So, I apologise. But yeah, 9:15, I think it's in Wilberforce, lecture room 2, but we're going to take the lid off what you're supposed to do. Shh. I know it was a great joke, but isn't that good? You can tweet it later. 9:15 on Friday, we're going to go through what you'll be doing for the coursework, taking a look at the game and the line of business app. So that's a good one to turn up to, so you can spend some time over Easter prepping it. So, wait for conversation to die down. Conversation dies down. Yes, good. Abstraction is the art of stepping back, I say. It's going from toothbrush to thing you might sell in chemist stock to thing you might sell to, I don't know, thing. But thing is basically object, I would say. So we're kind of back off there. So you go from toothbrush to a thing you might sell in chemist shop to thing you might sell, and then you stop. So everything is a thing I might sell, so away I go. It's a way of looking at things and actually stepping back from that specific and going to what is a particular exemplar of. So you can do this for pretty much anything around the place. When you're building a system where you're thinking about a class hierarchy, then you're going to end up doing abstractions. So here we go: current account, deposit account, credit card accounts, baby accounts. The bank needs to handle those, and it needs to handle those plus any new ones that come along, because that's how these things work. And so we do this. We have a parent account class, and we have a baby account that is a child of that, and deposit account that has different interest rate behaviors, and you have to give it notice to withdraw money and all that kind of stuff, because that's how those kind of accounts work. So we have this idea that we pick up the deltas, differences of behavior, and we pop those in the child. There's another level of stepping back though, which is that I can decide that there's certain things that you need to be able to do, and I'm going to just sort of say, well, every account we have to pay funds in, every account we have to withdraw funds, every account we have to set the name, every account to read the balance. These are all things that accounts might want to be able to do, but they might not want to do them all the same way. We do this a lot in games. We do this a ton when you're writing games. In a game, you have a sprite, and the sprite moves around the screen and does stuff. You may want some sprites that chase the player, some sprites that run away from the player, some sprites that are the player, some sprites that are the missiles, and then there's the background that's animated and all that stuff. So all these sprites are going to have an update behavior, and it will do whatever it is that makes that sprite updated. Now, as a game designer, I don't know what any of the sprites will do internally, but I don't really care. I'm just going to say all the sprites have to have an update behavior. I'll call this 60 times a second. You deal with it in your own way. So what we're doing now is we're stepping further back to a position where I'm not really going to consider what these things do. I'm going to figure out the things that they have to be able to perform. I mean, the way I see it for a game sprite, there's two things I quite like. I guess it's a third. If you include drawing, we've got draw yourself, update yourself, and reset yourself at the end of the game. And so every single sprite in my game has to do those things, but I don't know what they are for that particular sprite. So abstraction means, and we'll see how to after the break, as it were, abstraction means I can specify a requirement that objects should do these things without having any idea myself of what they actually have to do. It's a bit like being the boss, where you can ask your employees to do things that may or may not be impossible, but you don't care because you're the boss and just tell them to do this stuff. So abstraction is a bit like a situation where you just tell the thing to do it in its own way, and then off it goes. So bottom bullet point is important. Exactly how you provide this behavior varies from one object to another, but they all have to do it. So what I'm doing is I'm mandating that you need to do this as opposed to exactly what it is that has to happen when it is done. And that's kind of, I'll put this slide up now and take a look at it, and I'll come back here after the break. But you see, what I'm doing here is I'm saying that if you want to be an account, if you want to extend this class, you need a set name, a pay in funds, or withdraw funds. There is a W. It's very hard to see because the ink's a bit worn on this slide. And then a get balance method as well. So this guy's a template, and we'll talk more about templates after the break.